And this morning, I'm just going to give you a little update about a project that we've been doing in coordination with NDSU, mapping protein throughout wheat fields with on-combine protein analyzers. So I just wanted to start off with this picture, just to give a quick little background, just to give it a little visual, kind of what a little visual about what we've been seeing in the field. Obviously, you can see there's a yield map of a field, a wheat field up in northern Minnesota up on top, and we've got a protein map of that same field down on the bottom. And you can see there that there's a lot of variability going on in the protein map, and comparing it to the yield map. And so part of this research is investigating, what is causing all of that variation within the field. And to get a little handle on what really drives protein content and yield for that matter, both yield and protein content result as an interaction between genetics, so the varieties that you choose, the environment that variety is growing in each particular year, and the management inputs that you put into that variety in that field each year. And so the two biggest things that are going to affect your yield and protein the most are going to be how much water is available to that crop during the season, and then secondly, how much nitrogen is available to that crop during the season. And both of those are going to be, some of those things might be within your control or out of your control. And firstly, they're going to affect yield, and then they're also going to affect protein. So both the available water, available nitrogen, and yield are all going to influence what your final protein content is at harvest. And so since part of what you get paid at the elevator for your grain has to do with your protein content and whether or not you meet that 14% grain protein content, it can sometimes be advantageous to try and manage protein if at all possible. But referring back to that previous slide, so looking at genetics, our environment, our management, things that are out of our control are going to be how much water you get, unless you're irrigating, some of the few irrigation fields that we have in Minnesota. But for the most part, we're looking at dryland wheat. So things out of our control are going to be rain and the kind of soils that you're growing your wheat on. Things within our control we have are variety selection and nitrogen management. And that nitrogen management is going to encompass your nitrogen rate, how much nitrogen you're putting down, when you're putting it down, and whether or not you're choosing to vary those inputs by your soil types across the field. And so looking back at this first picture, I can see overlaid a very generalized Sergo soil map just to get a general feel for what the soil types are kind of varying throughout that field. And there's a sand, you can see the sand ridge there's a sand ridge running through the middle of the field, and we can see that the yield is lower up on that sand ridge. It's a little higher elevation, it's sandy, there's less water available. So it's reducing the amount of biomass that you're going to have there, which reduces the amount of starch and yield that's accumulated during the season. So when you have less yield, less starch, you're not diluting your protein quite as much in those kernels, and that's how you result with a higher protein content. And so when you have higher yielding areas, you usually get lower protein content because you have a greater dilution within that kernel of the actual amount of protein in each kernel. And this is something that you guys know intuitively. You see this when you're out harvesting in the combine. You see the yield going up, yield going down, the protein, the color of the grain changing. So this isn't something new to you guys. You know this intuitively as you're combining. So getting to why we might want to study protein variability. So why should we be studying this and wanting to learn more about it and wanting to learn more about what are those most influential factors affecting protein content, whether it be the rain, your soil type, your texture, your organic matter, what elevation, how elevation plays into it and interacts with your soil types and your inorganic matter. And can we, by studying protein variability across the field, can we identify protein management zones is if we are able to identify protein management zones, can we use our nitrogen more efficiently? And by doing so, can we increase our wheat profitability, which is something that's becomes more and more important these days, trying to increase our wheat profitability with the prices that we have. And so if we can identify these protein management zones and can identify which factors are most influential, and whether or not we can manage those influential factors, what can we do next? What can we do after that? Is it possible for us to shoot for a protein goal like we do with yield goals in those zones? Can we bring up those high yielding, low protein zones into, high yielding medium protein zones or high protein zones? And should we pull back nitrogen on those low yielding, high protein zones? If you're getting a low yield and you find that you're getting 15%, 16% protein in a low yielding zone, can you pull some nitrogen back on that area? But of course, all of these things are going to change every year, depending on that environment factor. What is our weather going to be like? How much rain are we going to get? And so that's where attempting or trying to see if we can predict yield and protein content based off of something that's more easily accessible, like imagery or in-season vegetation index scanning with like maybe a green seek or something like that. Can we use that as a proxy to estimate what we might end up with yield and protein content? Maybe try and make some in-season management decisions. And so what we've been doing with this project, we've been using on-combine protein analyzers to map protein content over wheat fields for the last few years. And we're trying to build up a database of multiple years of protein maps for each of these fields, so we can look at not only how protein is varying within a field within each year, but what is the stability of those zones from year to year. Now that we've been into it a few years, we can finally start to look back and see how protein zones change from year to year. And we've also, part of this project, we've also been working with imagery collection with satellites and drones to see if we can relate that to our in-season imagery, and looking at residual nutrients, our soil nutrient content, soil texture, soil type, and working on spatial analyses to kind of synthesize all of these data. So it's not quite as straightforward as what regular, small plot research is. And so, as I mentioned before, we're using combine-mounted protein analyzers. We're working with a company from Australia called Next Instruments, and working with their CropScan 3000H is the machine. And how it works is that it has a grain sampling unit attached to the clean grain elevator on the combine. And so grain samples are taken about every 10 seconds or so, 8 to 10 seconds or so, although they're working on tightening that gap up a little bit. And so those grain samples are scanned near infrared light, and those near infrared light readings are transferred into a spectrometer that's actually located inside the combine. So that there's a box in the combine that's essentially the same as what would be a tabletop analyzer at your grain elevator would be. So now that box is located in your combine, and it's attached to a touchscreen monitor that you have, so you can see the protein going up and down as you're combining, and it's mapping it in real time, just as you would look at it on a yield monitor. And so this is what the setup actually looks like mounted on one of the combines that we're using. You can see there, that's the sampling unit without the cover there on the left. And then there's that spectrometer box that's on the floor in the combine with the monitor display above it in the cab. And so the two sites that we've been working with for the past few years, we have one grower that we've been working with up in Roseau, Minnesota. We've been working with him since 2017. So we've been collecting protein maps for a few years, although unfortunately we did run into a hiccup this year and lost our 2020 data. But thankfully, we have that second location working on a unit mounted on a combine working near Thief River Falls, Minnesota, and we've been working with him since 2018, and both those producers have been really great to work with. The soils that these farmers are growing on are predominantly loams and sandy loams. We do have some fields that have sands and clays mixed in together. So some fields are pretty even, some fields are pretty variable. So we get a good mix of field types, of field layouts to make these protein maps on. Something that we added in this year is I took two fields we selected, one from each producer, and installed water table monitoring wells so they could just at 4 points spread across each of those selected fields to try and just measure depth of water table throughout the season, so we can compare that back to our end of season yield and protein maps. And you can see this picture of these there. So pretty much what it entails is installing a bunch of mini wells. You can see on the left there we've got an 8 to 10 foot well point that we augered a hole, stuck it down there in the ground, backfilled, sealed it off with some clay towards the top, and then was able to go back throughout the season and monitor depth to water table. And some other things that we are comparing these protein maps to is topography, elevation, how that's playing into our yield and our protein maps. You might have seen this slide before, how nitrogen fertility or lack thereof can influence yield and protein, or sometimes not yield. It doesn't show up in the yield, but it does show up in the protein. So nitrogen may have gotten to be limiting to yield had it gotten a little bit worse. So this particular slide, that red area was only shorted about 20 pounds of nitrogen. It had an effect on protein, but not on yield. I've been looking at some drone imagery. Fortunately, I was having a problem with some of my drone images, so I don't have any very good ones to show you guys quite yet. So this is a images from this year, protein map, NDRE map. And this is another different field, kind of similar concept. Some NDRE. So NDRE, that's normalized difference red edge. It's similar to NDVI, just a different way of calculating vegetation index. So NDVI, that usually maxes out, that measures biomass. And once the canopy closes and we have full canopy closure of the field, the NDVI kind of maxes out, where this NDRE index is more of a measure of chlorophyll or canopy color. So that way you can differentiate patterns after canopy closure later on in the growing season. So we can see some of those patterns consistently showing up across the imagery, yield maps, and protein maps. And then, as I mentioned before, now that we've been at this for a few years, we can start to look at zone stability, comparing protein maps from different years. And so that's what we're looking at with this slide. Here we can see a protein map from 2018 on the left compared to a protein map from 2020 on the right. Both seasons had a nitrogen-rich strip within the field outlined towards the top there. 2018, the enriched strip really didn't show up, but in 2020, it was very, the enriched strip was very apparent in the protein map. And so that might have indicated that at least around in that field, nitrogen may have been limiting protein, which isn't surprising this year. And something a little encouraging or interesting to see, we can see down at the lower left-hand corner of those maps. They are different colors, but you can see that the lower left part of the field, lower right-hand part of the field, excuse me, in the lower right part of the field, in 2018, we had a low protein year. It was a high yielding area. And in 2020, it was wet, and part of that field drowned out towards the bottom. But that field was maybe a little bit lower yielding, but had a lot higher protein this year. And even though whether it was high or low protein, that changed from this year to year, but the zone is still relatively in the same area. And so that's something that is encouraging, or we'd like to see and examine more maps to see if those zones stay in the same general areas, whether or not they're flipping from year to year. High protein, low protein, high yield, low yield, that's going to depend on the weather, which is the complicating factor in all of this. And so this is actually called a hotspot analysis map of that same field. Those protein maps that we just saw, this is an analysis or a spatial analysis that you can run, just identifying hot and cold spots, statistically significant hot and cold spots of protein in those maps. So in 2018, you can see we had higher protein in those red zones and lower protein in those blue zones. In 2020 map, those zones may have flipped, but we can see higher protein and lower protein zones. And so we can use this map to help identify maybe some protein management zones. Add a few other layers in there too, but just to help delineate some zones. So some either future uses or things we'd like to keep looking at with these maps as we keep collecting more and more data. Like to use these protein maps to calculate nitrogen removal or nitrogen use efficiency. Use these maps as a means to maybe validate some in-season protein predictions based off of imagery, whether with drone or satellites. Possibly integrate the idea of maybe segregating protein into different bins at harvest, or maybe possibly blending it yourself before hauling into the elevator based on protein premiums and discounts. And also look a little further into using protein maps to create VRN application maps. All right, and that is what I have so far for today, is a little update for what we are doing with our on-combine protein mapping. And I'd like to thank the Minnesota Wheat Council for funding this project, and also Joel Ransom for serving as my advisor on this PhD project through NDSU. And we have just a few minutes for questions. So if any of you watching have any questions, you should be able to type those into the chat box. And I can try and answer those quickly before we move on to our next presenter.
I have one question for you. How much N do you apply for an N-rich strip?
Okay, so we had one question in the chat box. How much N went on into the N-rich strips? And for these projects, we've just been doing a 1.5x rate. So the nitrogen rate in those N-rich strips is 1.5 what their applied rate is. You can also do a 2x rate is a common thing for nitrogen-rich strips. And just be aware of how much N you're actually applying. In a different trial project that we looked at one year, the grower did a 2x nitrogen-rich strip, which ended up being like 300 pounds of nitrogen, and his nitrogen-rich strip got really burned. So if you're thinking about applying an N-rich strip, just be consciously aware of how much N you're actually applying.
Next one, what rates of N were being applied, and what is the correlation between N rate and protein level?
So we had another question, correlation between nitrogen rates and which rates were applied. And I would have to get back to you on that. Nitrogen rates varied between the growers. It's generally between 120 and 140 pounds of nitrogen went on. Each year, one grower top dresses UAN, and the other grower does not. Correlations between nitrogen rate and protein content. I can't remember that off the top of my head. I'll have to get back to you on that. One thing to note, though, we will be talking about this more at our On-Farm Research Summit that Minnesota Wheat is going to host on January 20th. And so I should be able to have a little bit more information for you about this project then as well. So if you guys would like to tune into that, it will also be a virtual conference. We'll look for more information about the On-Farm Research Summit on January 20th coming out on our Minnesota Wheat website and through our publicity as well.
Yeah, one more question that we can go.
All right, one more quick question and we'll turn it over to our next presenter.
It looks like VRN would surely make a difference. Do you agree?
And we got a comment about VRN making a difference, and yes, I would agree that VRN definitely has a potential here to help us reach a more even protein map, bringing up those high yield, low protein areas to try and get those areas more to 14%, and to maybe consider pulling back some management on our higher zones if needed. But I need to do a little bit more looking into this to decide what the specific management actions would be. But yes, I do think VRN has some applications here. All right.